learn about deletion of a node from circular English at any position. Now this is the prototype for delete at any position. So the return type will be integer and the function name is delete at position and the head node will be passed as struct node double star head comma and position. So position will be defined. So this is defined as after B I want to delete node C or third element in the circular image. So third element starting from head node A. So B will be second node and C will be third node. So that will be deleted from the circular image. Now the approach is as usual we have seen in deletion of node at begin and deletion of node at the end. Now we will take two pointers P and Q. So P will point to previous node and P will point to current node. So basically P will travel till the last node D. So how do you check that this will traverse to the last node? P next will be not equal to head. So that will allow this pointer P to traverse till last node D. And the meantime we have to keep track of the previous node. So Q is the another pointer we have declared here along with head and P. So this will keep track of the previous node. Now, so according to the algorithm, we have taken in another integer value k is equal to 1. So we have to initialize k is equal to 1. So that will keep track of the position. So we'll check the condition in the while loop that k is not less than position. The position value will be 3. Till that position we will traverse. Okay. Or we can traverse till that last time. So node part traversing is done by p is equal to p next and position is tracked by the one variable that is k. So each time you traverse to next node, we will increment that one. Okay, so now we are at head node. So we'll start P and Q also initialize to head node. Okay, so now we have traversed to the next node. So P next is not equal to head and K is less than 3. So we'll increment K plus plus. Now we are at B. So P pointer points to the current node that is at B. After reaching B, we will check the condition once again. Okay, so we have not reached the position 3 that is will be node C and this node C will be deleted. So next we'll travel to the C. Now we are at B now. So P is pointing to B and Q is pointing to previous node A. And already you have increment K that variable to another value 2. K is equal to K plus plus. So K plus 1. So that will be 2 now. So K is equal to 2 now means we are at the position second node of the linkage. So we are at B now. So we'll check once again the condition whether you have reached the last node or you have reached the position. So we have not reached at the position C. So we'll traverse next and increment K as well. Okay, so we have now reached at the P and Q also pointing to the previous node B. Now P is at C, that node is going to be deleted. Now the condition in the while loop has been broken, so it will stop here. K3 not less than 3 because it is already equal to 3. Now it is equal to 3, so it will stop here. And we will reassign and adjust the pointers of previous node and current node. Okay, so these green marked nodes are already visited. So after traversing, we have reached C. Now we are currently at C. So and the key pointing to the previous node B. Now we have to adjust those nodes, and finally we have to free node P. P is the current node. So we have to break the link. P next you can say equal to null, and Q next will be before assigning null. So we have to assign that Q of next will be now P of next. What is P? P is at C. So C next, that is D, will be the current address of Q's next, that is B's next. So because C is deleted, so D will be the next node of D. For that purpose, B's next will be D. So how do you assign those address? We have already pointer P Q, which is pointing to B. So Q next will be current node is at P at C, so that P is our next. And then finally we will free P. Okay, so after deletion, the list will be, the circle list will be like this: A pointing to B, next address of A is equal to B, and B next address will be D, and D next will be pointing to the head address that is A. So thus the deletion has been completed. Now look at the coding part. Okay, so we have already declared a function name is deleted position. We are passing the struct node dot head, add the address or the first address of the circular list, and int position. Position is here is 3 because the third node will be deleted. Now you can say we will declare two pointers P and Q of node type node, struct node star P and star Q. Now we were to initialize k equal to 1, keep track of the number of nodes. So there will be while loop while P is not equal to head and k is less than position. We will increment k plus plus and Q is equal to P and P is equal to P minus. Now look at this block, while block. So k plus plus, it is incrementing each time up. Okay, so to keep track of the position value, it will check whether it has reached the particular position at which the node will be deleted. So, and after that, the previous node P will be assigned to the queue, and P will traverse to next node. So P equal to P next. The yellow mark line is representing the P has reached the next node, and Q will store the P's address before traversing. That's why the blue line is saying that Q equal to P. Q will lose track of keeps track of previous nodes address. Now doing this, we have reached, suppose we have reached last node and we have not found any position. So we can simply write P, if P is equal to null, it is return null, then we can say position is not found. Otherwise, in the else block, look at these two statements. Q next is equal to P next. So Q is pointing to previous node. Now we have seen in the diagram that is B. So that next will be D. So what is D? Okay, we have not reached at D. We are at C now. Okay. So how do we go? Simply we can write B next. So C next will be D. So that address is assigned to Q next. So we have broken the previous node's Q link and assigned to the current node's P next address D. After assigning this, you have to simply free the P. You don't have to write P next will equal null. You can simply free the P. That node is already deallocated from memory space. Now, simply you have written P data. P points to data. That value, the integer value will be returned because we have already declared the return type of this function is the person is int type. Okay, so we can simulate this and try to run this, and it is well defined for at the beginning or end and at the end also, and we have to give the value for k for sorry position so that it will be delete the node at any position. So begin at the begin k is equal to 1, at the end the length of this circle. So here is k is equal to 4. So if you have to delete last node d, then you have to pass the total number of nodes in the list, that is k is equal to 4. So that will simply remove the last node. Or at any position you have to check that number of the index of the node in the circular list. Here in this example we have deleted C node, that is the third node of the circular list. Okay, so this is very similar to deletion in single link list, but the check is to there is one slight difference that you have to check the last node pointing to the head node. So that you have to check that it has reached the last point. In single link list, you have to check the last node is next address will be null. Okay, so we have successfully deleted a node at any position in the circular link list. Now in the next section we'll see some application of circular link list. Then we'll go circular link list using doubling.